Next we are going to discuss about a differential amplifier. So this is the circuit for the differential amplifier. So we have the non-inverting input, and since we need a ground reference, we are adding a pull down resistor called RG. Okay, this resistor is called pull down resistor, and we name this as V2. Okay, and this is R2. So the inverting input is given through a feedback network. Okay, and this is where the inverting input is given. Okay, V1. Okay, this is the feedback resistor, and this is R1. Okay, here we have the V0. Okay, so if you look close, if we have ground here, then it's an non-inverting case. Okay, and if we have ground here, if we ground this part, and if we give input here, then it's an inverting amplifier. So the difference amplifier is both inverting and non-inverting amplifier. Okay, it has both the inverting and non-inverting part. Okay, so in order to solve this differential amplifier, we are going to use what's called a superposition principle. Okay, superposition principle. So superposition principle states that the combined solution of the differential amplifier, that is the solution of inverting part, okay, let me name it as inverting and non-inverting, is nothing but the individual sum of the solution of the inverting amplifier and the solution of the non-inverting amplifier. Okay, so it may look odd as an equation, but if we work out, we can simply understand this thing. Okay, so in order to solve this differential equation, first we are assuming that we are going to ground this non-inverting part. Okay, so if we ground this non-inverting part, then the output voltage due to the inverting part, okay, V minus, and this is V plus. So the output voltage due to inverting inverting voltage can be given by, so if we make V2 equal to 0, then V out of minus. Okay, so this is the solution of inverting part. Okay, the V out due to the inverting input. Okay, so this V out of minus is given by, it's simply V in, it's the inverting amplifier formula. Okay, so it's V1 minus V1 times RF by R1. Okay, so let it be equation 2. Okay, so if we next we make V1 grounded, so if we ground this part and give input to this part, okay, then we have, so before solving this, we have to know what's the voltage at this point. Okay, so the voltage at this point is nothing but the V plus. Okay, so V plus, so if we make V1 equal to 0, then the output voltage due to the non-inverting input. Okay, non-inverting, this is the solution of non-inverting. So this V out due to non-inverting input, right? So this is nothing but V out of non-inverting is nothing but V plus. Okay, so the input voltage, okay, this is the input voltage, V plus times 1 plus RF by R1. Okay, so this is by non-inverting formula. So we have to find this V plus. Okay, so this V plus is nothing but the voltage divider formula here. Okay, the potential difference across the resistance Rg. Okay, so we have an input voltage of V2, so the potential difference across Rg is nothing but the V plus, and it is given by V2 times Rg divided by Rg plus R2, right? So if we substitute this in 3A, okay, let it be 3A, let it be 3B. So substituting 3B in 3A, we have, so we have to substitute this here. Okay, so therefore the output voltage due to the non-inverting input is V2 times Rg divided by Rg plus R2. Okay, so this is the V plus, and we have a remaining term, which is 1 plus, or let me write it in full form. Okay, so it can be written as R1 plus Rf divided by Rf, right? Sorry, R1. Okay, so if we choose, so next, so the total solution, so this is equation 4. Okay, so the total solution due to superposition principle, V out is nothing but V out of due to the contribution from the non-inverting part and the voltage output due to the inverting part. Okay, so this is the V out due to the differential output voltage. This V out is the differential output voltage. So we have to substitute equation 4 and 2 in 5. Okay, so substituting equation 2 and 4 in 5, we have the differential output V out equal to, so this one, okay, let me copy this one. This one times plus, sorry, it's minus V1 times Rf by R1, right? So this is the voltage due to output voltage due to inverting terminal. Okay, so if we choose Rg equal to Rf and R2 equal to R1, we have V out equal to V2 times, so instead of Rg we have to put Rf, right? Rf divided by Rf plus, instead of R2 we have to put R1, right? R1 into R1 plus RF divided by R1, okay, minus V1 times RF by R1. So this is the usual inverting output. So we can cancel this and this, and we left with V2 times RF by R1 minus V1 times RF by R1, right? So we can write the output voltage as RF divided by R1 times V2 minus V1, okay? So this is the differential amplifier, okay? So this is the output voltage of the differential amplifier, and this RF by R1 is the gain, okay, differential gain. So again we can choose RF equal to R1, then we have what we have, an unit gain differential amplifier, unit gain differential amplifier. It's given by V out equal to V2 minus V1, okay. So this is the formula for differential amplifier.